Look at these values: 7, -4, 3/5, 0, pi, and the square root of 2. Without a specific system for organization, a list like this can look like a random collection of unrelated symbols. Over the next 5 minutes, we are going to sort these into 5 distinct categories. By the end of this video, you will have a reliable method for identifying every number you use in your daily life. We will test that method immediately. Once we've built the system, you'll be asked to classify 5 numbers against the clock in a final challenge. To get ready for that test, please find a pen and a piece of paper now. Grouping these values changes how you approach math, shifting the focus from memorizing individual digits to recognizing a predictable hierarchy. This hierarchy starts with a simple horizontal line. 0 marks the center, with positive values right and negative values left. We call every point on this line a real number. If it has a specific location on this axis, it belongs to this set. This line encompasses the measurements we use in the physical world. If you can measure it or count it, it lives somewhere on this scale. To organize the real numbers, we start at the center with natural counting numbers: 1, 2, 3. Moving one step outward, we find whole numbers, which includes natural numbers while adding 0 to the set. We expand again to include the negatives. These are the integers, a group that contains our counting numbers, 0, and their negative opposites, like -1 and -2. The final layer of this group is the rational numbers. This category covers values that can be written as fractions, which we see as either terminating or repeating decimals, like 1/2 or 0.333. Because these groups are nested, a single number often belongs to every layer. Take the number 5. It is natural, but because it's inside the other circles, it is also a whole number, an integer, and a rational number. This rational family operates on a clear fractional logic, providing a structure for numbers with predictable boundaries. Not every number on our line fits into those neat circles. There is a separate group called irrational numbers. Together, the rational and irrational groups make up the entire real number system. An irrational number cannot be written as a simple fraction. Its decimal goes on forever without ever ending and without ever forming a repeating pattern. The square root of 2 and pi are the most common examples. These categories allow us to describe different physical phenomena. A temperature of -5 degrees is an integer. A price tag of $2.50 is a rational number. The ratio of a circle's circumference is irrational. These classifications reflect the different ways we measure and interact with the world around us. Ready your pen? You have 5 seconds to identify the set for each of the following 5 numbers. Number 1, 7. This is a natural number, our innermost category. Number 2, 0. This value belongs to the whole numbers. Number 3, -4. This falls into the integer set. Number 4, 3/5. As a fraction, this is a rational number. Finally, pi. Because the decimal never repeats, it is irrational. Completing this sequence proves you can accurately identify how these different sets relate to one another. You've successfully sorted the main categories of the real number system. Here is a summary of the definitions we've covered, along with the examples from our challenge. Take a moment to screenshot or copy this list so you can refer back to it during your next study session. With these 5 categories clearly defined, you can now identify the logic behind any number you encounter on the real number line.